Okay, for topic two, we're going to look at understanding bar graphs. Okay, so as a definition, let me get my on. Okay, as a definition, we have that a bar graph is a type of graph that uses horizontal and vertical bars to represent the quantity of each item in a data set. So if you can, well, I'm old, so I went to elementary school in a different era, y'all, but if you can envision like late elementary school, maybe early middle school, you would have had a math teacher that would have brought in a big old bag of M&Ms or Skittles, given each of you a little cup of Skittles, and you had to like count them and separate them by color, and then you made this one gigantic bar graph. You're like, okay, how many brown M&Ms are in the bag? How many green M&Ms are in the bag? How many red M&Ms are in the bag? And so forth, okay? So when you're dealing with bar graphs, you're dealing with generally pretty straightforward, simple sets of data, nothing too wacky. But you're going to have two things that you're looking at. You're going to have something like, imagine the M&Ms, the color of the M&Ms, and then the number of those M&Ms in the bag. So that's one like super basic example of um, how you could use a bar graph. You could use bar graphs to represent the birthdays. So like imagine again you're a kid, you're in some math class and the teacher's like, "Hey, what's your date of birth?" And then they would count how many students had birthdays in January, February, March, all the way through December. So it's got to be like something where you're looking for how many of something. So there's got to be some quantity compared to something that's not necessarily a number. Okay? So like a thing and then a quantity, okay? So there needs to be a scale included on your graph. So we're going to have a horizontal axis and a vertical axis. So if you've ever had an algebra class, these are generally called the X and Y axis, but we're just going to say vertical and horizontal. So you have to have some scale that tells you that the numerical axis, it's going to have to tell you like how much each like tick mark means. So I might have something like M&Ms on the bottom. Okay. So we could have brown, blue, red, green, yellow. Are those the colors? Anyway, it doesn't matter. And then you would have the number of M&Ms on the other axis. So you'd have to have some scale that tells me how much like each tick mark counts. So I could say, let's count by five. So we'd have like 5, 10, 15, 20, something like that. Okay. So you have to make sure you have some kind of scale included in your graph so you know what the numerical data represents. Okay. And then the height or length of the bar is used to determine the quantity for each bar. So in this case, the way I have this set up, we could say, okay, there's 11 brown M&Ms, there's 15 blue M&Ms, there's 16 red M&Ms, there's 14 green M&Ms, and there's 10 yellow M&Ms. I just sketched that real quick, okay? But that's what you're looking at with a bar graph. So the height of the bar in this case represents the quantity of each item. You could also do this vertically, where along the horizontal axis were the numbers, and along the vertical axis were the different colors of M&Ms. And then you'd be measuring the length of the bar, not the height of the bar. Same premise though. Okay, so the advantage, the scale that is included with the graph helps with accuracy, but again, it's not going to be like you're gonna, when you're doing a bar graph, if you're dealing with huge quantities, the scale might be by hundreds or by thousands, then it's not going to be super accurate. So this is going to be much more accurate if you're dealing with smaller quantities. The higher the quantities get, the less accurate your scale is going to be, but it's not a terrible way to visualize data. Okay. All right, so in the following example, it says answer the question about the data shown in the bar graph. The following bar graph, that should say shows the number of endangered species in the United States in 2017. Things were really popping off in 2017. We had wheat production, we had endangered species. It was wild out there in 2017, y'all. Okay, so let's look at this. We can see that at the top it says how many U.S. species are endangered. That's just kind of like a little quip. It's like a little get your attention thing, okay? Along the horizontal axis, we have the different types of animals. So we have amphibians, birds, fishes. Is that how? I don't know. Insects, mammals, and then reptiles. And then along the vertical axis, we have the number of each species. So you can see here that we're incrementing by 25. So the scale on our vertical axis here is by 25. Okay. So part A says approximately how many mammal species are endangered. So mammals are represented by this giant horse, okay? Now we can see that this line right here is 100. So it's just shy of 100. And this is where you have to be kind of careful because this bar between 75 and 100, this distance, I guess I should say, between 75 and 100 is pretty small and it's not incremented at all. So we just know that the number of endangered mammals in the US is somewhere between 75 and 100, much closer to 100 than to 75. So I would say this is going to be maybe 95-ish. Okay, so again, not super precise. If you're dealing with smaller quantities, you can be more precise. The larger your quantities get, the less precise they're going to be because you're having to eyeball this distance here. So let's say this is 75, and then we can go 80, 85, 90, 95, 100. So I'm saying we're at about 95. Okay. Now, next up, it says, what is the approximate ratio of endangered reptiles to endangered birds? Write the answer. I said birds. Write the answer as a reduced fraction. Okay, so let's look at endangered reptiles. We're told that reptiles are at 45. You can see for some reason this one has this dotted line right here. So reptiles are definitely 45. And then birds, let's see what we have for birds. Birds, we're at just a smidge over 100. You can see right here, well, right here is 100. We're just a teeny tiny bit higher than that. So I would say like 102. I'd say not quite 105. For me personally, if I was grading this, I'd be fairly reasonable with you. I'd give you a little wiggle room on either side. So if you said 45 to 100, I'd be okay with that. It's probably a little bit more, but not quite 105. Okay. So we could say 45 to let's go like 102. Okay. And in that case, it's as reduced as it's going to get. 42 and 100, or 45 and 102, they're not going to reduce. So we would say this is approximately our answer. And again, we're having to eyeball. You can see here, if you look at this little corner, that orange goes just a smidge above that scale for 100. So we're just a little bit more than 100. Okay, so 102, 103. Okay, finally, part C here. It says, if the table represents approximately 510 endangered species, what percentage of those species are types of fish? Round to the nearest tenth of a percent. So let's look at fish, okay? So endangered fish, we are way up here. So this is 150, this is 175. So let's say that's 155, 160, 165, 170, 175. I'm going to say about 165, okay? So we're going to say there's approximately 165 endangered fish species, okay? And then we're told that the total is approximately 510. So what is the I can't speak today. What is the base? What is the amount? Okay, we're looking for a percentage here. So we need a base and an amount, okay? We know the total quantity considered is always the base. That's going to be the 510. And then the fish is going to be some portion of the total number of endangered species. So this is going to be the amount. Okay. Now, in the previous example, when we were talking about wheat, we did the percent proportion. Let's do the percent equation this time, just so everybody has a preference usually when it comes to whether they use the proportion or the equation. So I'm going to try to always flip back and forth. Okay. Now, the percent equation is the amount equals the base times the percent, but you do have to be really careful with the percent. You input the percent as a decimal, and then if you're solving for the percent, the answer is going to be in decimal form. You then have to convert it to percent form. So let's fill in our information. We have 165 equals 510 times whatever our percentage is. So in order to solve for P, we want to divide both sides by 510. 510 divided by itself just divides out to be 1. So we get 1 times P equals, well, 165 divided by 510. And we're going to mosey on over to the calculator. So let's see, do I have it up? Yes. So what was that? 165. Hold on, let me actually go back to my worksheet. 165 divided by 510. Okay, so we get 165 divided by 510. And we get 0.3235. Now remember, when you're dealing with the percent equation, if you're solving for the percent, it's going to give it to you in decimal form. We have to convert it back to percent form, which means we need to multiply it by 100. So let's multiply by 100 here, and that's going to give us 32.35. So if we were to round this, say, one decimal place, 32.35, the second 3 is what we're rounding. the 5 to the right of that tells us to round up, which makes this 3 a 4. So we get 32.4%. All right, so we're going to say approximately 32.4% of, let's rewrite that. 32.4% of the endangered species are fish. Okay? So there's your final answer. So that's a bar graph. Again, it's got to be pretty basic, straightforward information. You're going to have some kind of item and then some kind of quantity, and you're comparing this through some kind of similar group. So in this case, we were looking at endangered species. We had the endangered species broken into different types of animals, and then we had a corresponding quantity. Okay, so again, it's not the most precise, especially as your quantities grow and grow and grow and grow, because trying to eyeball between 75 and 100 can be a little bit hard. So again, rounding is involved, but just do your best. Okay, let's see. There we go.